this is what all of us should do is think about every feature from a security perspective, even before implementing it, just during the planning phase. Ask yourself questions like, what can go wrong? Because then you will cover the unhappy paths, and usually those are the ones that lead to vulnerabilities.
So our next guest is originally from Hungary. So if you want to get shouted out for your lousy security, he'll have all the original words for it. Give it up for Greg.
So, hi everyone, my name is Greg, and today I will talk about OWASP Top 10 for Rails developers. Just a quick question, how many of you have heard about OWASP before? Amazing, great. So, I will still explain what OWASP Top 10 is. It's the top 10 most found vulnerabilities in web applications. The list was updated last time in 2021, and next update is coming out next year. And I will go through the list from the bottom to the top. The first item on the list is server-side request forgery. We are talking about server-side request forgery when a malicious actor can make a request from vulnerable server to internal or external resources. This can be used to access restricted resources and exfiltrate data and bypassing firewall rules or security controls. Here is a graphical demonstration of an external server-side request forgery. An attacker sends a payload to a vulnerable host, and the server-side request goes back to the attacker. This can be used to leak IP addresses. For instance, if you put your site behind Cloudflare, you want to hide your IP, but if you have a server-side request forgery like this, attackers can find your IP address and DDoS your site or do other malicious things. The other example is internal server-side request forgery, which is much more dangerous and interesting because the payload is sent to the vulnerable host, which sends that to something on the internal network like Redis, and then the exfiltrated data gets sent back to the attacker, which can lead to more serious issues like data leakage. And it's very common in webhooks and when you are doing unfurling of URLs, because in those scenarios, the user can control a URL, which the server later makes a request to. To prevent and mitigate this issue, you should validate your user supply data before using it for requests. You should use network segmentations, so your incoming traffic and outgoing traffic are on a different network interface. They have a different IP. You can block everything on the one which you are using for the outgoing traffic, so you don't give an attack vector for the malicious users. And you shouldn't send raw requests back to the clients, because that makes data exfiltration very easy, make hackers' lives more difficult. And also, you should monitor your logs for suspicious activities, because that might tell you that you have an issue and you should fix it. The next item is security logging and monitoring failures. As I just mentioned, you should log all suspicious activities, because those can help you to identify security issues and fix bugs. Logs don't work much unless you are monitoring them, so set up alerts. For instance, you can set alerts for elevated numbers of login failures, which might be an indication of a credential stuffing or a brute force attack, and you might want to act on preventing that to escalate. And don't log sensitive information. Don't log passwords, don't log credit card numbers, because if someone finds a vulnerability in your application, local file inclusion, for instance, they can read your log files and they can get access to valuable information. In Rails, this is actually pretty simple. It has a built-in parameter filter, and it has some defaults, but you can extend it. The defaults doesn't really cover what most application needs, so if you don't have this in your app customized, please go have a look and put whatever sensitive information you have in your app into this list. The next item is identification and authentication failures. This is a very big topic, so I will just touch the surface. And I want you to just discuss what I think is a minimal viable authentication. You should have strong password policies, validate passwords for complexity, and make sure they are not in any data breaches, because those are out in the open. Use multi-factor authentication at least for the password reset if you have an email-based one, because if someone gets access to your customer's email account, and they can just do a password reset and get access to their account on your service. Use generic messages at authentication failures. When somebody tries to log into your website and the password is incorrect, don't tell it on the site. Just tell, we can't find an account with these credentials, because otherwise it can be used to enumerate your customers' names, your usernames. The last one is use rate limiting, because without rate limiting, it's very easy to brute force or do a credential stuffing attack these days. Technology is just really fast, so it's better to block malicious clients. And use strong cryptography, prevent timing attacks. That's also very important. And now the question is, how can you achieve all these in Rails, right? For validations, super easy. Active model validations, you can validate password complexity with a few lines. With a regular expression, there are 10 different ways to do the same. And for leaked passwords, you can use a gem called Pound, which uses a Have I Been Pwned API. It's a one-line change in your code base, really simple, and then your customers won't be able to sign up or change their password to something which was in a data breach. And for two-factor authentication, if you are using device, you can use device two-factor or the ROTP gem. And a very common mistake with two-factor authentication is when after a password reset, you automatically sign in your customers. And that one skips the two-factor authentication step. If you are using device, this happens by default. So when you go back to your work, please double-check that you don't have this issue in your device setup. For strong cryptography, you can use the hash secure password, hash secure token, and all of the new Rails helpers, because don't throw your own crypto. It's very difficult, very complicated, and it's easy to make a mistake. Also, to prevent timing attacks, you can use some Rails helpers, which is the authenticate by, find by token, and all of the new helpers. They prevent timing attacks. This is also complicated. Don't try to do it yourself. It's going to be probably vulnerable. And for rate limiting, Rails 7.2 has a new built-in rate limiter. This is really great, because it's really simple to set up, no external dependencies. And it behaves kind of like a before filter, so you can set only or except to control which actions you want to run this on. And you can set the to the number of requests you want and use within for the period, within the period you want to allow. After that, the client gets blocked. And, or not blocked, actually throttled. And by default, it uses the IP address to group the requests. You can change it if you want. You can press a call label. And by default, it also, as I just mentioned, it renders at 429 too many requests. And you can change this if you want to. You can have a custom message, you can have a custom redirect, or you can just block the client entirely. And for storage, as I mentioned, there are no external dependencies. It uses the Rails cache store. You can set it to a separate store if you want to separate your cache from your rate limiting data. And that's the built-in rate limiter. If you are on an older version of Rails, or if you want something more powerful, you can use Rack Attack. It has more features, but it has Redis as a dependency. So choose the best for your use case. The next item is vulnerable and outdated components. So you should check periodically for vulnerable dependencies and always update those. Because if you have a vulnerable dependency, maybe on the second day, someone will try to exploit that in your application for sure. You can use Dependabot if you are on GitHub to do this. Rails 7.2 comes out with a default GitHub Actions CI file, which sets up Dependabot to run periodically. If you are on an older version of Rails or you are not on GitHub, you can use Bundler Audit. And the next item is security misconfigurations. This is also a big topic. There are a bunch of things which could be included in this category, but I will just mention a few of them. For instance, the first one is don't enable development features in production. The one I saw a few times is the enabling verbose logs in production by accident. Probably the developer were debugging something, they wanted to see the error logs in production, they forgot to turn it off, and then they leaked the secret KBase because it's included in the error page. And another thing is the lack of authentication on Sidekick UI or mission control. Really easy mistake to make. You just set those gems up, you deploy to production, you hook them up without authentication, and someone can access your data. The next topic is insecure design. So this is what all of us should do is think about every feature from a security perspective, even before implementing it, just during the planning phase. Ask yourself questions like, what can go wrong? Because then you will cover the unhappy paths, and usually those are the ones that lead to vulnerabilities. The next topic is injection, which is mainly SQL injection, but also NoSQL injection. And Active Record is very good at preventing this, but there are still a few APIs where you can pass raw strings, and they are getting passed to the database without sanitization. For instance, calculate, and all of the methods which are alias to calculate is average, count, maximum, minimum, sum. If you pass a user-controlled string value to any of those methods, that can lead to a SQL injection. For instance, if you have a line item sum and you let the user control the attribute or the parameter, which, like total by, this one would lead to a SQL injection. There are also other methods, delete by, destroy by, exist, and all of those on the slides, which can lead to the same issue if you pass a user-controlled string to these methods. If you want to see a more extensive list, there is railssqli.org. It has broken them down by Rails versions. So if you're an older version of Rails, this is really helpful to see what is vulnerable, because there are, in Rails 7, a few of them were fixed, or Rails 6 actually. And there is another issue which a lot of people don't really think about. It's called second-order SQL injections. This one happens when a user-supplied value is saved into the database and later used in your code base in a background job or in another page, and it's passed to an insecure API. For instance, I found this one during a penetration test. It's a simplified code to demonstrate the issue. So the user were able to create reports for themselves and then render those reports later. As you can see, they were able to set a group and the columns, which was like ticking checkboxes. And then if you went to the show page, it was displaying the report by calling select and group with those values. It's coming from the database, right? But it was controlled by the user before, so this one led to a SQL injection. The next item is cryptographic failures. We already touched a little bit on this. If you need encryption, don't throw your own. Use the ones built into Rails, because you can trust that much more. And Active Record has a great encryption library now. You can use deterministic or undeterministic encryption. You can easily rotate your keys. Everything is really nicely set up. And if you need secure passwords or secure tokens, Rails also got your back. We have great helpers for those. And the next item is broken access control, also known as authorization issues. This is the most common vulnerability in my experience, because it's easy to make a mistake. So rule number 1, use strong authorization. Make sure they are also not just configured, but they are also enforced everywhere they need to be enforced in your application. And always use a whitelist approach, because when you introduce a new feature, you might forget that some user roles should not have access to that feature. It's always better to have someone complaining to not being able to access something they should than someone having access to something they shouldn't and you don't even notice it. One other thing I want to mention is UIDs are not replacing authorization. A lot of people think if I use UIDs, nobody can guess the IDs, so they can't do an indirect object reference. But the thing is, UIDs can be leaked. I found leaked UIDs many times in my experience, and they can also be brute force, but that's really difficult, but leaking is very, very common. So don't think if you have UIDs you are safe from authorization issues. And the other common issue is the foreign keys. So when you have a foreign key relationship, so you have, let's say, a user who has a portfolio items, and you store the user ID, and you allow the user to set that in a request to something else than their own user ID, then they can create records in someone else's account, which is not really good for security, because then your customers will think that you don't pay attention to security, and they might just leave your application. This is the most found issue in my history. And I was told to keep this talk short, so I tried to aim for a short one. If you want to talk about any of the things in more detail I mentioned, find me, talk to me. I'm very approachable. I don't bite. You can follow me on Twitter at Greg Molnar. And I also run this community-driven newsletter with a few folks called This Week in Rails, which covers the new changes in Rails every week. So subscribe to that if you are interested in the latest news in Rails. And I also would like to thank everybody for attending and the organizing team for creating such a great conference. And thanks for having me. And see you next year. Thanks, guys.